In this video, I want to alert you to a small adjustment. It's easy to miss, and it doesn't really have anything to do with safety, but it will make your experience using a table saw just that more enjoyable. And it has to do with setting the angle stops for the angling of the blade. So let's come here and take a closer look. This wheel, the wheel on the front on table saws, is always about blade height, okay? And there are no stops on that. I mean, the blade's either below the table, somewhere above the table, or all the way up as high as it can go. But the wheel on the side is all about angle. And adjusting the angle stop is all about making sure that the blade can't go past 90 degrees when you want it to be 90 degrees. So in other words, you crank the handle and the blade stops positively at 90 degrees. Most of your cuts are going to be made at 90 degrees. Or the other extreme, 45 degrees. So when you crank that handle back, all the way it will go in the other direction. You want the blade to stop reliably at 45. So you don't have to keep checking it all the time. Now, one tool that makes this really easy is something that's generically called an angle cube. It's made by different companies. This one's called Tilt Box. But essentially what it is a very precise digital level. And I'll show you what I mean by that. The purpose of this tool is to tell you the angle of the blade in relation to the table. And you turn it on and you'll see it's got a digital readout, and depending on how I rotate it, it is telling me the angle in degrees from horizontal, or more or less horizontal. When I say more or less, this is what I mean, because you don't actually care whether the blade is, say, perfectly plumb or not, perfectly straight up and down in relation to the earth. What you care about is it 90 degrees or 45. So the reference surface for this is not the earth itself, as with a regular spirit level for building, but the reference surface is the tabletop. So you start using these things by putting it on the tabletop. They will all have a 0 button. And it's very important that you zero the tool before you take the next step. So we're at 0 now, as you can see. And the sides of these things always have magnets. It's a good thing saw blades are made out of steel and magnets work on them. But when it's zeroed properly, then you move it over and you let it stick to the blade. One thing to keep in mind when you've got one of these things on your blade is that it must rest only on the body of the blade, not on the tooth, because all carbide teeth extend out past the body of the blade. That's so that the kerf of the saw, the groove that it chews through the wood, is slightly wider than the body of the blade, so there's no friction, or very little friction on the side. And with the cube in place, you now have a very accurate reading on the relationship of the blade to the tabletop. Now, I should mention, these devices are extremely sensitive. I mean, this one gives you angles down to 1/100th of a degree, which is a lot more precision than we need. In fact, it can be kind of frustrating because, after all, we're not machinists, we're not tool and die makers, we're not milling an engine out of a block of steel. So even 10 or 20/100ths of a degree is not going to be significant when you're doing woodworking. But still, it's a very good guideline. And the objective here is to adjust the 2 stops that are within any saw. One stop is the positive stop for 90 degrees, and the other stop is the positive stop for 45 degrees. Those are the 2 extremes that you're going to deal with, and most of the time you're going to be making 90-degree cuts anyway. So you just want to be able to crank that blade, and when it stops cranking, you're at 90 degrees. Now, different saws are going to have different locations of these adjustment stops. And they're not usually easy to get at, but luckily you don't have to tweak them very often. So if you take a look at this saw here, you can see the 45-degree stop through this curved slot here. And you want to put a wrench on that, and there's going to be a lock nut and then an adjustment bolt. So you loosen the lock nut, you adjust the bolt until you've got your angle correct, either 90 degrees or 45, depending on which one you're working on, and then you lock the nut on the bolt. Now the precision here is so great that even just tightening the lock nut can throw the adjustment off a tiny little bit, probably more or less insignificantly, but you should be aware that you might have to take a couple of runs at this, because adjusting the bolt is one thing, tightening the lock nut is another, and it can shift things a little bit too. But the idea is that this angle cube is going to show you exactly where the blade is in relation to the table, and that's a very valuable information. Before these things came out, we would be doing this sort of work with a highly accurate square. I like to use a machinist square or an engineer square. They're great to keep in your tool pouch so you can check 90-degree angles on parts as you're doing them. But this is quite a nice accessory to go along with that. And if you come over here, you can just sort of see it in action. As I crank it over, the angle's changing all the time, and it just stays put because that thing is magnetized to the blade. And the idea here is you want to make the machine as easy to use as possible with as little frustration for you as possible as you go about your work. And if you can count on 90-degree and 45-degree settings at the extremes of the wheel, then you're all set, and you can actually get to work and work more enjoyably too.